Matrix multiplication. The brain one GPUs are computational with that.
Hello everyone and welcome to the 9th edition of the latest tech trends webinar by Oradea Tech Hub. Today we have, as usual, a very interesting subject that somehow goes in line with the subject we had last week, meaning autonomous cars, but from a different angle. We will talk today about graphics processing units, GPUs, as we know it, from Bitcoin mining to autonomous driving. So today with me, I have Alexandra Bara. It's a pleasure to have you, Alexandra.
Hi, thank you for having me.
Yeah, it's a pleasure. Thank you for accepting our invitation. As we always do, here is the structure of today's webinar. We have a first part where we talk about our subject, and then we'll have a short break where it'll be the time for you to answer a few questions from Alexandra. And then we'll proceed to the second part where we'll talk further about our subject today. And then in the end, we have a Q&A session where we will answer your questions. So speaking of that, please go if you're watching this live, please go to oradeatechhub.ro/live. From there you can watch the live webinar and also interact with us through the Slido widget from the right side of your screen. So there you can ask questions, and also you will see there in the break the questions from Alexandra. Okay, so Alexandra, please, in the beginning, tell us more about yourself. How did you end up at AMD and in USA? You're from Romania, right?
Yes, I was born in Oradea, so it's been a long
Yay.
road to get here. But representing, I left my hometown when I was 18 and came here for college. And I studied in Virginia for about 6 years. I have an undergraduate degree and a master's degree in computer science.
Nice.
And after I left the university, I started work in the industry, and my first job was at Intel. I
Nice.
worked on servers. Yeah, it was quite the change going from academia
The real
to
world.
the industry, the real world. Yeah. It took a little bit of getting used to a faster pace, but
Okay.
I liked my job a lot, and I was there for about 3.5 years. And like I said, I worked on servers there as a software engineer. And then I had a job at Samsung for a little bit at a Samsung research center here in Austin, Texas. Um, I worked on CPUs for mobile platforms. So we were
Okay.
doing research on the next CPU for the Samsung phones.
Nice.
Um, and most recently, I've been with AMD for just over a year now. And kind of transitioned into GPUs here at AMD.
Okay.
I work in a division called machine learning software engineering. So we have like an entire software stack that operates on top of GPUs, and I'm here to tell you a lot of the things I've learned in the past year about GPUs.
Yeah, I
And
bet
I
it's
think you find
interesting.
it, yeah, I hope you find it as exciting as I do.
Yeah, yeah. It'll be exciting, especially for a lot of people who are watching us live, and we also have people that are watching this at a later time. So it will be helpful for the community. Thank you. Okay, you have a presentation for us, but before that, I was going to ask you. You mentioned you went to the USA for college. It was
hmm
on a scholarship, or you just
Yes, yes.
okay?
Universities here are really expensive,
Yeah.
and we're talking about like $50,000 a year
Wow.
on average. So I had a full scholarship, an athletics scholarship, which meant I played a sport for the university, and they paid for my tuition. So I played tennis throughout college,
Oh,
Division I tennis team. So that was really fun.
nice, nice. Okay, okay, thank you. Let's go to our subject today, GPUs. Uh, can you tell us more?
Yes. So should I just start my presentation?
Yes, yes,
I think
please
you
go
guys are
ahead.
looking at this first page. Okay, so maybe I'll start talking a little bit about what I do at AMD, because this is sort of a start into machine learning and why GPUs are so useful in this field. So at AMD, I work on this software stack that's called ROCm. It's open source. It's an exascale platform for accelerated computing, um, and we are it's language independent, so that's something we really care about because we want to make it accessible to a lot of our users and our customers.
Okay.
And we are basically trying to make it easier for the users to use our hardware and have really good performance for their applications, whatever those might be. Um, so this is what the software stack looks like. You can tell it goes all the way from the CPUs and the GPUs that we produce at AMD, and that's what we run on in-house, compilers, and all the way up to HPC applications, which are high performance applications. So I don't work on all of these. These are all very complex libraries and platforms. Um,
Yeah.
I'm mostly involved at this layer, at the MIOpen at math libraries layer. So MIOpen is
Okay.
also open source. Um, I write some code there, but I mostly use another application that is not open source and runs MIOpen a
Okay.
lot of
So,
time.
what does it do? Am I open?
Um, yeah, so MIOpen is a deep learning library, meaning it runs these machine learning algorithms, I guess you could call them. And if you want to go more in depth, specifically, it runs convolutions, batch normalization. These are sort of neural networks,
Okay.
and they're very complicated mathematical procedures. Hence, they run on GPUs, and I will explain later why that's such a great thing. Um, but it's basically one convolution at a time. And on my team, we run this, say, 120,000 times.
Wow.
And the issues we run into doing that is that we have a restricted time frame that we need to finish those jobs in, which means we can't just let it run for a year and then look at the output. We have to run it very efficiently within, a decent time frame, which currently is about a week, what we call decent, but it used to be where it would take us like up to a year to do this.
Wow.
So we always have to keep it very efficient.
Okay.
And then we send out the results to our customers. Um, okay, enough about what I do. So to talk about GPUs, I think it's important that we distinguish from CPUs.
Yeah.
Um, So CPUs, everyone has in their computers. If you have a laptop, you have a CPU, and if you have a desktop, you definitely have a CPU. You might also have a GPU in your desktop. CPUs are really good at taking a lot of input from different peripherals, like your keyboard, your mouse, your screens, or whatever other attachments you have. There's a lot of components to the CPUs. And it has a lot of memory. It can handle a lot of software threads at one time, but it's not that great at doing a lot of mathematical work.
Okay.
And that's why GPUs came around. And this was news to me. I had to Google like why we have GPUs these days, and if you look into it, there's sort of a little bit of debate online on who invented the first GPU,
Yeah, of course.
and I think both IBM and NVIDIA like to claim that it was theirs. I'll let you decide who came up with it first.
Yeah.
But IBM were the first ones to, I think they did use the term GPU, graphics processing unit. And what it did back in the 80s, they came up with this unit to specifically display text. And when we think about it, that was such a huge deal back then.
Yeah.
Now, yeah,
Today
now
is
it's like,
something
yeah,
expected from every
yeah.
every screen.
It's really hard to imagine that that's what used to be cool back in the day. Um, but then so yeah, IBM didn't really go with it too far. It displayed text and then later displayed some more symbols and mathematical symbols and things like that. But it really became popular in the 90s when NVIDIA used their first GPUs um, to display pictures
Okay.
and start more work on video games. So NVIDIA's been around for a long time, and they've been really good at designing GPUs specifically for playing video games. And I'm sure if you play
Yeah.
video games, you are familiar with this.
Yeah.
Um, so then NVIDIA likes to claim that they marked the first GPU with the
Yeah.
GeForce 256.
Okay. So that's a GPU that we know it. Yeah, and it
Yes,
runs more complex graphics on a screen
yeah, yeah, it was a
and
lot
not
more
on a screen.
complex by the end of the
Okay.
90s than it was in the 80s when it was displaying text.
Okay.
So what makes these GPUs so special is the fact that they can take a big task, they chop it up in smaller tasks, and it executes them in parallel. So
Okay.
compared to a CPU, a GPU has a lot more cores and is very, very good at doing parallel processing, assuming you write the software correctly. Of
Of
course,
course.
to run really fast on a GPU, you have to program your software in such a way that it can do a lot of parallel work. And then the GPU comes in and does that like really fast for you. So thousands of operation at once. These GPUs today are also really expensive. Um, I don't know what the bottom is, but I think it starts at around like $50 and it can go all the way up to like
A few
a
thousand.
thousand, a
Yeah.
couple thousand. Yeah.
Yeah.
Um, and so if you're into mining coins, I'm sure you have a lot of those expensive GPUs.
Yeah. Actually, a lot of people started started mining here in Romania because they had some money from the government for startups, and they used it to
To mine
buy.
coins.
Exactly. Yeah.
That's smart.
So
Yeah, I mean, when
yeah,
a
there you
coin is
go.
like $40,000, why not? There's a lot of
Yeah.
money to be made.
Yeah.
But there's also a
Well,
lot of people that mine these days. It's
and the energy is not that cheap, so
well,
yeah.
yeah.
Okay,
I will
sorry for the interruption.
I will apologize in advance for my bad memes. Um, I always feel like I pick the best ones, but anyway, so we're moving into the Bitcoin space now. As I was saying, GPUs can do thousands of operations at once, which makes it a perfect candidate to do some mining, whether that's Bitcoin or Ether or other cheaper coins. Um, so I'm assuming most people by now know what a virtual currency is. Bitcoin is the most popular one because um, I believe it came first and it got very popular really fast in I don't know what the year was when it reached like $20,000, but I want to say maybe a year or two ago.
Yeah, a few years
It,
ago. Yeah.
although it's been around since maybe 2010 or 11.
Yep.
But I don't think people really saw the value in the blockchain until later when it became sort of like a trading coin.
Yeah, right.
Um,
This is why we have a few stories with people that forgot about their bitcoins, and now
yeah.
they're trying to find their hardware, HDDs or other. Yeah,
Right.
some of
I
them.
heard about this
Yeah,
guy. Yeah,
yeah.
I heard about this guy who forgot his
His
password.
password. Yeah, right.
Yeah, poor guy. I hope he finds it. It's like winning the lottery now.
Well, yeah, there are not so many chances, but he still has like more
Two more
options,
tries?
two more tries. Yeah.
Okay.
Okay,
Oh
so
no. Okay.
yeah,
That's a little close. Um, so
but today people understand and see that Bitcoin and cryptocurrencies are something special and are something that will be in the future for sure.
yes, they are adapted by banks now, by a lot of companies that have to secure their transactions.
Yep.
What makes them so special, these transactions, is if you imagine like for a bank that's international, they want to make sure that not one transaction can ever happen twice. Like if you pull money out of your account, you want to make sure that you only do it once, not twice, and that also not someone else can do it instead of you.
Right.
So it's like a very good a security measure for them. And yeah, I know they used to be a lot of people used to be opposed to it, but then they saw the value in this blockchain, and it's become really popular with governments and banks now, and it's getting more adopted and regulated at the same time.
Yep.
So this is why this the blockchain is so important because um, you can validate transactions. But if you're a miner, you can also, while you try to validate transactions for, other people in the blockchain, you get rewarded with Bitcoin in this case, if you're mining Bitcoin, which is very profitable when it's like $40,000 for a coin. Of course, that's not how much you make this day anymore
Yeah.
because there's a lot of people doing it. So I read that back in the day, if you would mine, you would get rewarded with one Bitcoin. And now it's like, I don't know, an eighth of an eighth of an eighth or something like that.
Yeah.
Um,
It gets diluted over time.
yeah, you don't make as much now. Um, but it's really important that you validate the transaction first for you to get rewarded with Bitcoin. And so to do that, you need a very impressive mining rig, which implies lots and lots of GPUs that can do this validation for you faster than anyone else can. Um, and this is why you see even there's companies out there that have like entire rooms full of mining rigs, and I read about this company that mines about $70,000 a day in Bitcoin, and I can't imagine what their electricity bill looks like. I'm sure
Hopefully not not near that number.
I'm sure it's really high, and you
Yeah.
also have to cool these GPUs because they run really hot.
Yeah.
Um, and oh yeah, I put a link here to Satoshi Nakamoto, which is the inventor of the
Bitcoin.
Bitcoin. He has like a short paragraph on what the math behind the blockchain is, if you're interested in more details.
Okay, perfect.
So
So I'll use this as a reminder for everybody. If you signed up for a newsletter or for this webinar, you will receive a copy of this presentation in your inbox in the next days. Okay, so you'll be able to access the link and go over everything that we discussed here today. Okay, sorry for the interruption.
no, that's okay. I have a couple more links in here, so I think it's good for them to know where to find it.
Okay,
Um,
perfect.
so these are some fancy looking LEDs here, but this could be a mining rig. This is made of a bunch of NVIDIA GPUs, and they're really good at mining because they can execute a lot of instructions per clock cycle compared to a CPU. And they have a huge number of these ALUs, or arithmetic logic units, which can do math really fast. So if you want to read more about this, I have linked to Investopedia. It tells you why these GPUs are so good at solving these problems, and more details on how they're built to do this particular mining.
Okay, perfect. Uh, I'll interrupt you again. So just a reminder for everybody that is watching us live, if you have any question during our talk here, our presentation, please go to oradetechhub.ro/live, and you can type your question in the right side of the screen. Okay. Yep. So there we go. We have first question, but we'll address it later.
Okay. So I have found a nice video of what a mining rig looks like, and I'm gonna play just a couple minutes to show you sort of what the components are of a mining rig, including like the CPU and a GPU. Do you guys hear that sound?
No.
It doesn't matter.
Yeah.
I can explain it.
Yeah,
So
we
if
hear
we go
something,
here,
but
you can see all the elements of a mining rig. So it's got a lot of memory, it's got a CPU, which is important, and then obviously a lot of power supply and other things to connect these components. And then of course, you can see him here holding 2 GPUs. The more, the better. I don't think he's going to mine too much with this rig. But he's doing Ether, which is not quite as popular as Bitcoin, so he might be getting some Ether at the end of this. So I will fast forward to where he will plug in the GPU. So you can see he's already plugged in he has the motherboard there, the power supply and the fan, and he will plug in the GPU into the motherboard to connect it to the CPU. So all these components have to communicate and sort of work together to run the software. Power supply and a fan. Well, he seems to have an open system, so it probably doesn't get that hot.
yep.
And then I will move to the end of this where you can see him powering up the rig. There it is. He already has the software installed for mining, and that's basically what it looks like. It's, nothing too interesting, I guess.
Rows of metrics.
Yeah. I'm sure for some nerdy people that looks really cool.
Yeah, of course.
Yeah, so you can find this on YouTube. It's linked if you're interested more in what these rigs look like. Okay. So we can transition into machine learning now.
Yeah, you mentioned it in the beginning.
Yeah, it's a huge field for using GPUs. I think this is something I got off Wikipedia definition of machine learning. It says it's a study of computer algorithms that improve through experience. Basically, what experience is in terms of AI or machine learning, it means training. And I always like to give this example of machine learning as like a start to think about how you have to program like a machine learning algorithm or software, or how it should be working. And that's the example of opening a door. So as people, as humans, we've developed over billions of years into, we pick up really fast on things. Like when you're a child, you figure out how to open a door. It might take you a couple years, but you figure it out eventually. But if you think of the steps that you need to take to open a door, you have to sort of, first of all, you have to recognize that it's a door. Then you have to reach out, grab the handle, pull or twist, and then pull the door, and then walk through. So if you imagine programming this to a computer to do it, you have to tell them like every single step that is involved, from including like reaching out, grabbing, closing your fingers, and things like that. So it's easy for us as humans to interpret this, but when it comes to programming, it's really hard to tell a computer what to do. Sorry again for my bad memes. But yes, computers are dumb, which I guess isn't that fair because we invented them, so they're only as good as we make them. Yeah, so like I said, computers are not so good at really anything unless we program them to do it. And then not only do we have to program them to do it, we have to train them to recognize, for instance, a door. Like doors look very differently depending on where you are. Some have a handle, some open automatically. Some have like a metal frame you're supposed to pull, others you're supposed to push. So training an AI to do this means you have to have him like open doors, different doors over and over again, until eventually you hope that they will understand how to open a door they've never seen before, because they're already trained on so many other doors. And this training part is where the GPU come in. And I will show you, this is another video I have of what a neural network is. So machine learning is built out of what we call neural networks, and they're basically trying to mimic the neurons we have in our brain. And they're very complex. Obviously, they could be like just a simple layer, but if you're trying to do anything complicated, they can end up with like thousands and thousands of layers.
Okay.
So I will play this little video for you for about maybe 2 minutes, and it will show you how sort of how you tell a computer to recognize a number. And let me tell you that I know there's fear out there that AI is going to take over and replace us in real life.
Yeah.
But I will also tell you that up to maybe 10, 15 years ago, we were still training AI how to recognize the difference between a cat and a dog, or a letter. So I think we're fine for now. They're not going to take over anytime soon.
Yeah, so we still have a few more years or
Yeah,
decades.
I think our lifetime we're set. Maybe our kids might be in trouble.
Okay.
But yeah,
No.
I will play this for you. So here you have, it's explaining how do you recognize that a 3 is a 3. And basically you're like reading an image, and us as humans, we could tell that a 3 is a 3 because we've seen that before. But there's different types of 3s, people write it differently. So
Yeah.
the way an AI works is it will read this image and then decompose it into pixel by pixel, and then try to figure out what each pixel or each cluster of pixel represents. So even just making sure that that different 3 equates to some other 3 is a pretty interesting problem. So here it shows you how it pixelates the picture, and then it assigns a 1 to the image of 3. And so now it tries to figure out, okay, it's reading this part that has the one bit in it, and it tries to figure out, is this a 3? Is it an 8? Is it a 6? So it does this through a neural network, which is how an AI learns. And this neural network is basically you feed it some input, which in this case is a bunch of pictures of threes written in different ways. And then at each layer of this neural network, it's trying to learn, and the output will be like a yes or no. Is it, or maybe it could be, is it a 1, is it a 2, or is it a 3? So here you see it, the neural network is fed an image of 7, and then it recognizes that it's a 7. Then it takes a 2, and then it recognizes that it's a 2. So if you think about it, each of this layer, it has, this is a very complex neural network, but these operations here are done by GPUs. And why is because a GPU will take pixels from this picture and compute like some complicated operations on it, and then pass information along. So the fact that you can decompose this picture into pixels by pixel, like a 1 or a 0, that means you can parallelize this algorithm. So, oops. Here's another neural network learning if it's a dog or a cat. And the same thing as in the previous video, you see it's being fed pictures of cats and dogs. And then it goes through these filtering layers, and then it says, okay, it's a cat. Now, this might seem like very simple to us, but for some reason, this cat and dog and training neural networks with animals has been very popular. So you can see AIs out there being really good at recognizing cats or dogs.
Cats, yeah. Well, cats are famous on the internet, so.
Yeah. So I found this article, and I've linked it here on Forbes. So this was a problem, I guess, back in 2012 when we were still teaching AIs the difference between a cat and a dog. So these researchers, they showed a very, very large neural network, about 10 million unlabeled images from YouTube videos, and I try to make the AI, recognize what's in the pictures. And they found that this AI had like really strong feelings about cats. So you wonder why. And
Yeah.
it's kind of funny that that's what it would recognize, but it's been trained to recognize cats apart from dogs or the other way around. And so it's biased. Yeah, which is why I posted this bad meme here. I'm not scared of a computer passing a Turing test. I'm terrified of one that intentionally fails it. I think we're going to be okay.
Yeah, so how we detect that? That would be the
Right.
question.
How do we know they're not faking it?
Yeah. So probably the people that coded it, they know.
Yeah, it's a big problem in AI that they tend to come out biased, meaning like the programmer has a bias. So if I like cats more, I would feed it more pictures of cats, for instance. It's a stupid example, but that could happen. And then so I train my AI to like really like cats. And this is a big problem in artificial intelligence, is how to program an AI or train it in a non-biased way, which is really
Okay.
hard for us humans to do as well.
Yeah, I think this shows us a lot of what human nature is. Yeah.
Yeah.
Yeah. Okay, so I think if you're okay with it, it's time for a short break.
Okay.
And
Do it.
let's have those that quiz. So everybody who's watching us live, please go to oradetechhub.ro/live, and you'll see in a couple of seconds. Yeah, the first question from Alexandra for us. So the first question is, how many total bitcoins can be mined? Let's see how many people are familiar with Bitcoin. Okay, we can also vote, so let's do it.
Oh, I know the answer, so that's not fair.
Okay. There are still a few people that can vote. Okay. Let's see if there's anybody. Okay, so a few people answered. Actually, all people who are watching us answered, I guess. Most of them said 20 million. Is that correct?
That is correct.
Okay, so there is a finite number of bitcoins that can be mined.
Yes, and the big question is what happens when we reach that number? Then what?
They get diluted somehow?
Yeah, so we can't mine anymore. No money in mining.
Okay. Yeah, right.
We don't know. I guess we'll find out.
Yeah,
I don't know
but
how far we are from reaching that number.
I don't know it either. But the question is, do we need GPUs after we mine all of them?
Well, we still need to validate the transactions on the blockchain.
Okay.
You know, the fact
Okay.
that we get coin for doing work with our GPUs is sort of like a side effect of the primary reason for the blockchain is actually validating transactions. Getting rewarded with money is like a nice side effect, and it's a way to incentivize people to do it.
Yeah. But would people mine or have their GPUs plugged in and, you know, they need a lot of power and
Yeah, I
yeah,
don't
it's
I
gonna
don't
be
think like
interesting.
I don't think the average person will want to do it anymore if there's no reward.
Yeah, I think the banks and other financial institutions and other people that are invested in Bitcoin, yeah, will know what to do.
Yeah.
Yeah. Okay, so let's go to our next question. The next question is, what is the name of the most advanced AI in the world? Yep,
In 2021.
in 2021. Yeah. So, let's see how many people watched Silicon Valley, the show.
I'm a huge fan.
Yeah, me too. Brilliant show, by the way. I think we should have a recommendation section on our website with shows and movies to
Yes.
watch for the geek community. This
Yes,
is
good idea.
something you're not allowed to miss. If you're in the tech world, startup scene, you're not allowed to miss. And it's fun. Yeah.
I
Okay.
can see myself in that movie. I see my coworkers in there.
Yeah. By the way, you in which state are you? You're not in Silicon Valley, right?
No, I'm in Texas. I'm in Austin, Texas.
Yeah, the next Silicon Valley.
Yeah, I think
As I hear.
it's called Silicon Hills.
Oh,
Yeah, because we
interesting.
have hills here.
Yeah,
Um,
no
it's
valleys.
not a valley, so yeah,
But
it's Silicon
yeah,
Hills.
but is it silicon? Because I think we moved.
This is yeah, this is like the real silicon here. This is where all the semiconductor companies are at.
Yeah, great. That's great.
This is where Dell started.
Oh, right, right. Yeah, I've heard that a lot of companies and people are moving out from California, so the next few years yeah, we'll see a lot of movement in this space.
Yeah, a lot of them are coming here. I think
Yeah.
Oracle and Tesla were the latest big ones to move.
Wow, big players.
Yeah.
Okay, so I think we still have we have one question left. Most of the people answered Sophia. That was my answer
Nice.
too. Yeah, that was the correct answer, right?
I thought it was weird that you would call like such an intelligent AI Sophia, I expected a different name for it, but
Something more powerful, more.
Yeah, this it made it very human, I guess.
Yeah,
That's the point.
that's the point. Yeah. Okay, so what is your favorite dessert?
Yes, the
Well,
most
this
important question.
I'll go with the American one. Well, all of them are American.
Soft serve, I think, is not very American.
Yeah, you're right. It's more
It's a very
European.
European, yeah.
Yeah. Wow. I'm I'm really curious right now.
Which one it is?
Yeah, because everybody voted the chocolate chip cookies.
Mm. It's a trick question because the correct answer is all of them.
Okay, you got us.
Sorry.
But out of these three, which one is the most favorite?
I'd probably say the least favorite is the chocolate chip cookies if I had to pick. But I've
Ah,
become really good at baking them lately. So I might change my mind in a couple months.
okay.
I've had a lot of
Keep us
baking
posted.
chocolate chip during this pandemic.
Yeah, a lot of us cooked way more often than
I'm sure, yeah.
yeah we used to do. Okay, um, great. So let's go further. And I talked about in the beginning. I mentioned autonomous driving, self-driving cars. What's the role of GPUs there? Because last week we had a webinar with Timmy Guro, who is innovation leader at Volvo Cars, and
Hmm.
he showed us some very interesting stuff. And I'm just trying to connect the dots right now. Uh,
Hmm.
from what I see, GPUs are pretty everywhere.
They're everywhere these days. And
Pretty much everywhere. Yeah.
yeah, the way the internet likes to compare it the most, from what I found, is it will tell you that a GPU is like a truck and a CPU is like a Ferrari. Um,
Okay.
so basically, it means if there's a lot of load to carry, you want to use a truck because you can fit more of these mathematical operations in it in just one trip. And
Okay.
a CPU like will obviously get there faster because it's a Ferrari, but it can only carry so much at a time.
Right.
However, in autonomous driving, you need both of them. Um, and why is
Okay.
that? Is because if you so the example I gave here with autonomous driving is mostly the Tesla autopilot because I think everybody knows what Tesla is at this point. Although there's lots of other companies out there working in this field, um, but it it's GPUs are used in autonomous driving because they can process a lot of data at once. And when I say data, I mean if you think about a Tesla cars, it has um,
A lot of
it
sensors and
reads. Yeah, it has so many sensors. It reads
cameras.
like the surroundings, um, and by reading the surroundings, I mean it takes pictures. It looks at videos of what it's what it's going through the environment, and then it needs to read these pictures and figure out, is there a car in front of me? Is there a person? Do I need to stop? The complete autonomous autopilot in Tesla can, stop at a stop sign. So it needs to figure out that in that picture it's looking at in front of it, through the sensors, through the cameras, there is a stop sign. So just like we saw earlier with the number 3 and figuring out that it's a 3 in a picture, it would need to figure out that there's a stop in a picture. Um, so doing that, it has to do that really fast. So like it has to do it real time. And then it has to distinguish between the different things that it sees on a road. So let's watch a little video of the autopilot.
Okay.
And on the right side, you can see it figuring out what's in the picture. So the green is sort of like it sees the cars in front of it or the
Okay.
cars it might have an impact with. Um, it stopped at a stop sign. You can see it also recognizes sort of like you could tell it's maybe trees, but it's basically aware that it's driving. So it has to know that it's stopped or it's driving, and then it reads everything around it. And it has a lot of cameras. And I have a slide later that tells us that the Tesla autopilot operates with 2 CPUs and 1 GPU. So it reads everything through the CPUs, like all the sensors and everything, and then whatever it can offload to the GPU, like all these intense mathematical computations, it will do. And those are things like recognizing what's in the image. Um,
Okay.
it breaks down what's in an image. Obviously, it's learned. It's
Yeah,
learned so
right.
much over the training. So yeah, here I have a slide that, it tells you that anything that's compute intensive, it will offload to the GPU. So I just recently found out actually Elon Musk just gave out in an interview that he's going to move away from NVIDIA GPUs, and Tesla will be making sort of its own GPU. And I don't think they called it a GPU. I think it might be more of um,
Yeah, they always tend to invent the next thing.
yeah, and that's really good for us as clients
Yeah,
because we win in this. Whenever
yeah.
two companies battle over who makes the best thing, then we're
The
the
customer
winners.
wins. Yeah, right.
Yeah.
Very innovative company.
Yeah. So if it says that currently it can process 200 frames a second, then it says that it will replace that NVIDIA GPU with something that can process 2000 frames a second. And that is a huge difference.
Yeah. He always talks about 10x multiplication. Yeah. He doesn't like nominal numbers. Just
Yeah. I'm really excited to see where it goes because I think there'll be a Tesla car in my future. I'm waiting on them to make them longer distance.
yeah, actually they just announced a new model that can go the highest option can go to up to 800 or so kilometers per charge, and that's
When is that coming out?
in the next few months. In the next few months, it's a
800.
yeah, yeah. It's the new roadster. Yeah,
Oh, the fast one.
yeah, the fast one, the really fast one,
Yeah.
2.1 seconds for 60 miles per hour.
Nice. I bet it will
Yeah.
cost a lot too.
Well, it starts, I think, at 70,000, which is a lot.
Yeah,
Yeah,
it's a lot.
yeah, it's a new type of Model S.
Good.
Okay.
Well, exciting. Um, I have another video here, which I might just play for a little bit, but mostly what I want to portray on this slide is how many GPU hours of training the autopilot got. So if you have the full autopilot, it has 48 neural networks and up to 70,000 GPU hours of training.
Wow.
So you can imagine that is a lot of power through those GPUs. And in this video, which is just the autopilot itself, you can sort of see on the left side, it's trying to figure out what it's looking at. And this is happening really fast in real time. So the fact that, a GPU has gone from like in the 80s putting out like text on a
Text.
screen to doing this crazy stuff here, and it's
Yeah.
just amazing. And it's doing it really fast, and it's doing it really good. It probably could be better because I've heard of there's been some accidents with the autopilot. But if you trust it, it could take you places.
Yeah. It's just the beginning, I think.
Would you do it? Would you let like the Tesla car, if you get the full autopilot feature, would you let it drive for you
I think I would need a few rides to trust it.
to decide?
Yeah, yeah, if I trust it or not. Actually, I didn't ride in a Tesla. I just got into one just to, yeah, I had an exhibition, but I didn't have the opportunity to drive one.
Hmm.
Who knows?
I
I
have
think
been
that's the
in
future.
I have been in one. Well, so because I work in tech, a lot of my coworkers drive Teslas because it's the,
Okay.
fancy shiny new toys. So
Yeah.
we always like make them take us places so we can see what it's like. And I have been in, I want to say it's model, is it X, the one that has like the fancy doors coming up?
Yeah, I think so. Yeah.
Yeah, so it has the autopilot feature, the full autopilot feature. So it let the car drive, and I
Okay.
was sitting in the back, and I have to tell you, I almost got car sick. Because the way it hits the brake, it's so like it's not very smooth. It's
Okay.
more like a, yeah. So I was like,
So it
okay,
still
either,
needs more refining and testing.
well, maybe I'm just too sensitive. Everyone else in the car seemed to be okay, but for someone like me, I was like, no, I'm gonna stop, or you drive it, or I'm gonna like make a mess in your car, please. I mean, it was still very cool to see, especially
Yeah.
because I was sort of afraid that the road didn't have marks. So it wasn't
Oh,
marked. How, could you tell that there's two lanes? So I was like, oh God, is it
so
going to be able to tell that it's two lanes? But it did. It did.
yeah,
So
that's
we made
great.
it. Yeah.
Yeah, it's perfect.
So I
Okay.
posted here just a couple of other industries that use GPUs. I mean, really, it's in anything these days. Like oil and gas is a big thing here in Texas because, you know, companies are looking for new oil reserves. And so you do the image analysis. They'll take pictures of the ground, of the soil, and then analyze it to see if there's, pockets of oil there. Security and defense is a huge one. If you think of drones, things like that, sonar, um, infrared, and then NASA, obviously, and all the national labs here in the US doing research on what's out in the space. Manufacturing is a big one. Um, yeah, so I mean, it's everywhere. Anything that needs a lot of processing powers has
Yeah,
GPUs.
and apparently we like everything interactive. As I mentioned earlier, we had just last week the webinar with Timmy Guro, and we were
Hmm.
talking about AR and yeah, lots of this stuff, and all of them use graphics
Yeah.
because we want to see things, and we want to see things differently, more in a more immersive way.
Hmm.
Yeah.
Yeah, we
So
want a very natural interaction.
yeah, exactly.
And
That's the word.
yeah, I did see that webinar. I liked it a lot. I like what Volvo is doing. I think they're doing great stuff.
Yeah, they're. I think also they're on the good path, and
Yeah, maybe it'll be like the European Tesla.
hopefully yes. And I'm pretty excited for Timmy being there and moving things forward.
Yeah,
Yeah.
giving us the inside trading.
Yeah, exactly. And also, I think it's a pretty strong motivation for us because he's from our community and he made it there. And
Is he from Oradea as well?
yeah, he's Oradean jet be jet.
Nice.
Yeah, we're proud. Yeah, okay. So I have a question. So Moore's law, it applies
Hmm.
to CPUs, but does it also apply to GPUs? Or, and also, if yes, if does Moore
Uh,
law still works?
that was a big thing when I was at Intel, obviously. Uh, the answer I can give you is I don't know. But knowing what I know about Moore's laws, I'm sure there's an equivalent for GPUs as well. I mean, at some point, physics will be a barrier for how how many bits we can transfer,
Okay.
um, and how fast we can do it. And
Yeah.
our GPUs are so small. I mean, and we pack so much on them in terms of these cores. Yeah, I think there's probably going to be an upper limit to what it can do, and then we just end up making them bigger and bigger. Um,
Okay.
yeah, I'm pretty sure there's an equivalent for GPUs as well.
Okay. So for everybody that is watching and doesn't know what the Moore law is about, can you tell us in a few seconds about it?
Um, yes, I think what it is that at some point we reach a limit with physics where we cannot build smaller cores and make them faster because you can only transmit bits um, so fast. And
Okay.
so
Yeah,
we've
it's a physical
boundary.
limitation, boundary
Mm,
limitation, because of
yeah,
the nature of the material, silicon. But I heard they work on finding new materials like graphene or
faster
something like that.
materials.
Yeah,
Yeah,
they are
it it's
conducting
a
energy faster.
it's a big challenge.
Yeah,
Um,
because yeah, that's I think what Moore said was that every 2 years the processing capacity doubles and the
Doubles. Yeah.
price is cut in half.
Mm-hmm.
But that growth not is
Sustainable.
is not sustainable, and it slowed a lot in the last years, I guess. Yeah,
Yeah. I think what are we
but we'll
at?
see.
5 nanometers now, and I don't know. I haven't heard anything about making it smaller. We're there. We're reaching that
Yeah,
limitation.
yeah, but probably we'll find something else and we'll move on because that's what we do as the human species. We
I hope so.
always
Yeah.
learn. Yeah. Okay.
If not,
So
we can always just pack more GPUs and CPUs in a spot.
yeah, but then we have an energy problem, and we're very cautious about not, you know,
Cooling
not.
problems, electricity
Yeah,
problems.
yeah, and electricity is not so clean as we'd like to be. So there are, there are a lot of challenges to address in the next decades. So
Yes, we are not gonna run out of jobs, that's for sure.
yeah, the world needs us. Okay, so let's take a few. I mean, all the question. There are a lot of questions. I'm impressed. Good job. A lot of questions
Is it
from
a
our
good job
audience.
if they have a lot of questions?
Yeah, yeah, because
Maybe I just
people
didn't
are
explain it
interested in
well.
this. Well, we'll see about that, but I think you did a great job, and people want to know more about this. Okay, so we'll take them. The first one was from Viorel. We were talking about banks adopting Bitcoin, and he asked which bank adopted Bitcoin.
It's not as easy, and I can talk about the US. I don't know about the world. The problem we have here is with government regulations. So all the banks here in the US are looking into setting up blockchain transactions.
Yeah,
Um, but it's still the government is still putting out regulations as to how that can be used, and I don't know how far they've come out with in terms of I'm sure it's already in use, but I don't know to what extent.
yeah.
And so here in the US we have like Bank of America and Chase and all the big banks. I
What?
don't know about at home. I'm sure they're doing work on it too.
Oh, so they're doing work on it, but they don't allow transactions on Bitcoin, right?
No, I mean it's still not so much regulated here in the US.
Okay.
Like for instance, the tax, the IRS. I don't know what the Romanian version of the IRS is, but
Yeah, enough.
um, okay, they have just started taxing people on the money they make on Bitcoin.
Oh,
But it's sort of hard to track
Yeah,
who makes how much money on Bitcoin because it's hidden behind a blockchain, and then
yeah.
you can hide it even more.
It's
Um,
anonymous.
yeah, which is a good thing, I guess, but for IRS coming after you, and it's a challenge.
Yeah, well, we have a question about that. Okay, so Dave says, sorry for the newbie question, but I was wondering in the AI ML revolution, who's the powerhouse, the GPU or the CPU? Which is more important? And it's artificial
Um,
intelligence.
oh, well, you need CPUs to offload jobs to a GPU, but obviously GPUs are far, far ahead in the AI world.
Okay.
Although I have seen something about there being CPUs out there that are pretty decent at doing machine learning algorithms as well,
Okay.
but they
With
don't compare to how fast GPUs are.
okay.
And it mostly has to do with how well you program it.
Right.
So if you program it really well, you can fully take advantage of what's in a GPU. If you program it not so well, not so parallelized, then you can probably get similar speeds from CPU and a GPU. But when it comes to like machine learning, GPUs are far, far ahead.
Okay. So the most efficient way is to combine the two.
Tesla Autopilot, two
Yeah.
CPUs and one GPU.
So there we have our answer.
Yeah, basically
Per-
you use a GPU as an acceleration. So
okay.
you only let it do like the math, and then you let the CPU handle everything else.
Okay. Okay. Yeah. So somebody's asked, what happened to your tennis career?
I still play
Oh, that's
a
nice.
lot. I still play a lot because I can't give it up. I just don't play competitive anymore. I've
Oh,
done
okay.
it from when I was 6 until 22. I used to
Whoa.
play every day for a
Pretty
couple of hours.
extensive career. Should we
Yes.
expect next Simona Halep or?
I wish. I was never
Yeah.
as good as a junior, but I watch her all the time, so I'm really proud.
Yeah. We're also proud of her. Okay, so you still play. That's the game. Just
I
play.
do. I can't give it up. It's like it's a hobby now.
Okay, perfect. And it's also good for your health, so
Yeah. Plus, here in Texas, honestly, we have tennis weather year round.
yep, perfect weather for tennis.
Yeah.
Yeah, no
So
rain or just
barely
not.
rains. I mean, it's pretty dry. It's almost desert here. It doesn't rain, it doesn't snow, so you can play outside all year.
Okay, so if you want to play tennis all your life, go to Texas.
Gonna be hot.
Oh, yeah. Take some ice with you. Okay, so we have another question. Have you ever mined any kind of cryptocurrency? If yes, what cryptocurrencies do you prefer to invest or acquire?
I have not mind. Um,
Okay.
honestly, I work uh, I used to work on CPUs and servers and GPUs, and it's not really something I wanted to do in my off time as well. Um,
Okay.
I did buy Ether, and my husband bought Bitcoin, and my friends, I mean, we all talk about it. Everybody I know, and even whether they're in tech or not, they all buy some
Okay.
kind of coin.
Have you?
A couple of years ago.
Okay, so have you heard about Elrond, the Romanian cryptocurrency? They just
No, what is it
no.
called?
Elrond, Elrond.
I will look it up.
Yeah, they just passed the 1 billion in the.
Market cap?
Yep.
Oh, nice.
Yeah,
Maybe
and
I'll buy some of that.
yeah, they try to do what you just said about banks and the governments trying to figure out to correlate the financial system with the blockchain
Hmm.
cryptocurrencies. So I think they're onto something. They have a lot of meetings with a lot of important people in the US.
Is this a startup or are they
Yeah,
a bigger company? Okay.
it's a startup from Sibiu here in
Hmm.
Romania. Even Elon Musk mentioned them at one point.
Okay.
So they're onto something.
Okay.
And I know a few people that invested in the early
Hmm.
days, and
Hmm.
they are now seeing the first fruits of their work, so to
Nice.
speak.
Well, have you guys heard about what's going on with GameStop and
Yeah,
Redditors
and
and
AMC and all this.
yeah.
Yeah,
I'm not saying that's what we should do with the Romanian coin, but if we all buy into it.
yeah. There you go. So free publicity for everyone here. We're proud to see Romanian startups rise and conquer the world.
Yes.
Yeah. Okay, so we have another question from Viorel, actually. He's Romanian. Why would you validate a transaction with no reward? So does it mean that Bitcoin will go down at some point? We were talking about that.
Um, so I mean it's hard to incentivize people to do it if there's no monetary gain from it, obviously. Um, but at the same time, you can ask yourself the question, why would people put out open source code? You know, if there's not much to gain from it. I think you would do it for like to advance the technology or advance the space.
Okay.
But that's probably just the type of people that want to improve the world
Yeah.
without them having personal gains. Uh, Although if there is no gain, I don't think most people will be into it. And mostly because I mean it does require your energy bill is up, you know, you have to buy these expensive GPUs.
Right.
Um, and you have to pay for that somehow. So if I think if the incentive goes down and if we end up mining all of Bitcoin at some point, which of course we will, we either have to figure out a different incentive for people or
Okay.
it'll just end up being people that want to make the world a better place that do it.
Well, I think here is an incentive, not losing all your money and maintain the value of your money invested in Bitcoin. And this might be
Yeah.
an incentive just to
Why
preserve the
maybe
value.
here's an idea. What if we reward them with like dollars or some other currency?
Yeah, but how do we print them?
Maybe we'll just make another coin that has, I don't know, another 21 million. I still think that there needs to be
Inst-
some kind of monetary value for people to do it.
yeah, yeah, we'll see. But I think some institutions and big players will have all the reasons not to let the value go down and maintain the GPU
Yeah.
activity.
Yeah, I think you're right, but I think a lot of the validating the blockchain will shift from like you and me doing it at home to institutions doing it, uh, banks doing it themselves, you know.
Yep, yep. And there were a lot of pretty large transactions and in Bitcoin, and some people suggested that banks got involved and acquired pretty much of the existing Bitcoins.
I
So,
wouldn't be surprised if they did.
yep,
I'm yes, I'm always skeptical because we don't know who's behind any of this. Um,
yeah,
and
right.
I want to think it's people like you and me, but I'm
We
not
don't
that
really
naive.
know. Yeah,
Yeah.
we don't really know who Satoshi Nakamoto is.
I know, isn't that a miracle that with all like the FBI and the private investigators we have, we still haven't been able to figure it out.
Yeah, that's interesting and curious in the same time. Okay, so somebody says that I suppose the value of Bitcoin will skyrocket by the end of supply, but what about the usage of the blockchain anymore?
Oh, that's where the money's at. I mean, it's not even the coins. The coins is just the reward you get for doing it and for having more people do it. But the real value in these coins is the blockchain. I mean,
Yeah.
that is a huge, huge deal for online transactions because we have such big issues with, all
Right.
these attacks like spam and people infiltrating and trying to pretend they're you online and stealing bank accounts and things like that. And
Yeah.
and blockchain is something that can basically cure all of that. Anything that goes on online that can be corrupted can now be like a safe transaction through blockchain. And that is a huge deal. And that's the most important thing coming out of cryptocurrency is the blockchain, in my opinion.
Yep. On that, somebody asks, Lenuța actually asks, can you hack Bitcoin? If yes, why is so safe then?
Can you hack it?
I don't
Uh,
think so.
no, I haven't heard of it yet.
Yeah. Yeah. Up
Why
to
why
this
it's so
time,
safe? That is a very important question, and it's a lot of math behind it.
yeah.
I don't really know the answer myself, but something to look up for sure.
Yeah. And it's the same rule every time, the same math behind it, not some people that are deciding uh,
Yeah,
what's
it's just
approved or not.
yeah, it's just math.
It's just math. Okay. Um, Ioana asks, are there any IT communities like Oradea Tech Hub that you recommend, even if they are only online?
Well, I know of a bunch of them here in Austin.
Okay.
Um, And here in Austin, there's all kinds of different ones. There's a bunch that do like defense, security, and defense. There's a couple actually on blockchain because it's such a big deal. Lots
Yeah.
of them on blockchain. A lot of them on AI because that's, like a cool new thing. So one of them is called Capital Factory, which I go to when the world is normal. They have
Okay.
on Now they have a lot of online sessions, but I think you can attend even if you don't live here. Incubators, Capital Factory. There's a couple more. I think if you just Google because Austin is like the Silicon Hills, it's very similar to Silicon Valley, and there's lots and lots of incubators and startups and tech hubs.
Okay. That's great. So just Google might be your friend. Okay, somebody asks, do you believe Neuralink's chip will be compatible with human brains or will it give us overload?
I hope so. I heard there's some promising steps in treating things like Alzheimer and
Okay.
some neural dysfunctions. Uh, I mean, obviously, it's hard to test because
Right.
you. I don't know if we make like fake brains in labs these days.
I
But
doubt it.
I mean, how do you test it? You put it on a person with some kind of,
Yeah,
one of these.
I think they start with rats, but eventually they
Yeah.
get to people.
Yeah. I know we're making small strides towards improving it, and I know there's been some promising um, research out there on treating things like Alzheimer. And so yes, I think it will definitely be there. But here's the other question, like, how regulated is that going to be? I mean, I hope they don't just allow anyone to get a chip in their brain and then do whatever. Who knows what they're going to do with it? Um,
Well, look at the vaccine. We don't accept the vaccine. We accept the chip inside our brain.
Right, right. People are like scared that the vaccine is going to kill them. Then imagine like having a chip.
Yeah. Well, interesting times ahead.
I'm excited about Neuralinks. I hope it goes well.
Okay, for me it's a scary thing.
Yeah, for sure.
Okay, so somebody says, machine learning looks promising, but it seems an immature technology right now with multiple mediated failures in the stage of its development. What's your opinion?
Wow, that's a big attack on some of these national labs. Um, yes, I mean, obviously, it's so hard. It's such a hard problem. If because, like I said, us as humans, our brains have like what 6 billion years of progress made. You know, towards from like if you think that we used to be apes, we used to climb trees, and now we're like solving world problems. Um, AI is the same thing. It's really hard to program, and there's been so much stride made in the past 20 years that now we can just have like a fully autonomous car driving us around. But we're still, it's we're at just like the beginning of this section of or sector, I guess, if you want it, of artificial intelligence. And I think 100 years from now, there's going to be so much more capability, and it's going to be. I mean, it's already embedded in everything we do online. There's so much AI behind everything, but it's still we're just at the beginning. And yes, it's very. I guess it's like a child. This AI, you know, it's a child industry at this point, but it's got huge potential.
Yeah, like with all inventions, it's trial and error.
Yeah, I mean, you know, 10 years ago we were still looking at pictures of cats and dogs, and here we are driving, letting an autopilot drive for us.
Yeah. Okay. Well, we still have a few questions left, and people are just asking questions. That's all. Okay, so somebody says, is a diploma really needed in to work in the computer science branch? Do you need
Not
a
so much
diploma?
anymore.
Okay.
Not so much anymore, but
What
that's
do you need
something.
then?
It's something recent. You just need skills. You need like get a GitHub account, put all your work that you've done there. You still need some proof that you know what you're doing, that you know how to program. So you can't just show up in an interview and claim that you know how to do a lot of things. You need some kind of proof, and a lot more companies these days don't care so much about diploma anymore, but that's still a lot of them do. I mean, the big ones like Google now come up with they'll say something like, "We'll train you for 6 months if you come in with no diploma,"
Oh, okay.
um, but you still need a way to prove that you know what you're doing. So what I would suggest is put out some open source code and make it public so other people can see what you've done. And then have that, like that should be your proof. That should be your
Wow.
resume.
I'm thinking of this can be done in a blockchain, in the blockchain, to
I
validate your
mean,
skills. Like kind of
yeah, you do whatever you
universal.
want, blockchain or
Yeah,
not.
yeah. The future of university is the blockchain that does it.
Yes.
Yeah, interesting future. Okay, so somebody congratulates you. You're clearly top notch. Well done.
Thank you.
How do you at AMD guys feel about beating Intel so hard these days?
We're loving it. We're loving it. It's, you know, it's funny because I think like half of the people at AMD used to work at Intel, maybe
Yeah,
even
I was
more.
going to say,
It's such a small world, especially here in Austin. This is like the semiconductor mecca, and everyone has worked at like every other big company
okay.
in semiconductor. So, I mean, I have worked at Intel, and most of my coworkers have worked there at some point in their life. And if not, they might go back later. Um, yeah, but we feel really good about ourselves these days. I'm not gonna lie.
Okay. Uh, Two questions left. Do you see a good future for Pi Network?
For what?
Pi, P-I,
I don't know what that is.
Pi network. I don't know it either. It's a network that runs on Raspberry Pis. I don't know.
Oh, if it's Raspberry Pis, um, yeah, the IoT world has sort of slowed down. If we are
Yeah.
talking about IoT, um, I don't see
Well,
such a
no,
bright future for
I
it.
just yeah, I just looked it online. It's about they say they're the first digital currency you can mine on your phone. So
Oh,
it's micro mining kind of stuff.
I will look into that. That's interesting. I
Yeah.
mean, phones do have some pretty decent GPUs these days. I don't see why you would use a phone necessarily,
Well,
but
everybody has some old phones, and eventually, in the next 10 years, our today's phones will be old phones, and we can just plug them and let them mine for us.
it's a it's I guess it's a better option than keeping them like who knows under the couch or something
Yeah,
in your
but watch for the electricity bill because you might get surprised.
yeah, battery life on phones isn't very good.
Yeah,
I think it's cool that it's happening, but I'm a little bit skeptical of how it works because phone battery lives are pretty bad as they are. Um, I don't know.
yeah.
Maybe.
We'll see. Okay, so last question, Remus is asking, was it the master's degree that enabled you to get a job in this particular field, or was the computer science undergraduate degree enough?
Um, I'll be honest with you. I struggled to get a job. Um,
Okay.
and and I stayed for actually that's one of the reasons I stayed to do my master's is because I couldn't find a job with my bachelor's degree. But that was back in 2012 where yeah, the tech world here in the US was already pretty big, but I feel like if I would be looking for a job with a bachelor degree today, it'd be much easier than it was back then.
Okay.
Also, one thing I like to speak to is this bias in tech towards women, which used to be a lot worse back in the day, and it's gotten much better now as people are getting aware that this is
Yeah.
a problem we have. Um, I don't know that my master's helped me. It probably did. Um, honestly, when my manager hired me, my first manager at Intel, he said he was really excited that I play tennis. So maybe it was
Yep.
tennis, it was my master's, I don't know. He said something like, as an athlete, he likes that people who are athletes are better
Yeah,
um,
the
at sort of
mentality.
like, yeah, at going through the day, at prioritizing their tasks, at like staying focused and
More
things like that.
disciplined. Yep.
Yeah, so
So, yeah, you should either go to masters or in play
play a
soccer,
sport.
play tennis, or play a sport.
Yeah.
Yeah, discipline, perseverance. Yeah, that's what a lot of companies are looking for, and skills, of
Yeah,
course.
I mean, when your first job at a company, they will teach you things. They don't expect you to know much, honestly, coming out of academia.
Okay.
But what they do want to
Is
see
that
is
true
they
in
want
the
to see that,
U.S.?
yeah,
Okay.
they want to see that you can figure things out on your own, um, and that you're perseverant and that you don't give up easily, because it's a huge step between academia and the real world. And so nobody wants to like babysit you. They'll do it for maybe
Yeah.
like a year, but afterwards they sort of want to let you uh, figure it out on your own. And
Yeah.
that's a lot of what they're looking for in new hires.
Okay. Well, I think time's up. Uh, somebody just asked another question. How did you apply or how do you apply for an athletic scholarship in the US?
Oh, that's a good question. I wish I would remember more about how that went. There's recruiters that would. So I remember when I used to still play in when I was in high school, there were recruiters that would come to our tournaments and they would talk to you about, do you want to go to school and you have to apply. One thing I think helps is reaching out to coaches at universities
Okay.
and talking to them, and they'll ask for your resume and your results and things like that. So I think usually it's more either through a recruiter or through the coach, but it's not through like how regular students apply. You don't go like through their websites and send in your GRE results or your,
Oh, okay.
yeah.
Interesting. So I think that's it for today. A lot of new information. I really enjoyed discussing with you all these matters. There are a lot of interesting things happening right now in the technology space, but it's nice to see and discover more and more the technology behind it and how old stuff like GPUs that were invented back in the 80s are playing such a big role in everything we do in the digital space. Okay, so just for everybody that is watching us, just make sure you subscribe to our newsletter and also that you are subscribed on our YouTube channel, that you liked our Facebook page so that you will receive from us more news about the future webinars and also the materials from this webinar. I don't know, Alexandra, if people have more questions, how can they get to you?
I'm on LinkedIn, Alexandra
Okay.
Bara. Yes,
Okay.
you can. I work for AMD there on LinkedIn, so you can find me that way.
Oh,
And I'm
that's
happy to
perfect.
connect or answer people's questions.
Yeah. Well, thank you very much, Alexandra, for being with us today and for sharing your work and so much interesting stuff. Hopefully, we'll have another webinar in the future. Yeah,
Thanks for having me. Yeah.
it's been a pleasure. We want to thank our partners for enabling these webinars and helping us reach to you and bring you value. I also want to thank you for being with us today and watching us live, and also for if you're watching this later, thank you for watching us. Make sure you follow us on Instagram, like us on Facebook, and also subscribe to our YouTube channel. Until next time, bye bye, stay safe.